Hello, this is lesson 8.4, and today we're going to talk about regions related to circles. For the EQ, please note that it says first to explain. So yes, I want words. I want you to be able to practice how you explain things, and then find the area afterwards. All right, so we're going to talk about 3 different regions, and the first one is called a sector of a circle. So if you can see in the diagram, a sector is this shaded gray region that's between 2 radiuses, and an arc of the circle. So you can see that here's one radius, here's the other, and here's the arc. So it is bounded sector between the arc and the 2 radii. Also note this angle ACB is called a central angle. We've talked about that before. It's been a while. And it's because the vertex is at the center and the sides of the angle are radii, right? Sector. So it's like a slice of pie, pizza or apple. Sector. So you can see that it is part of a circle. So, So let's talk about the area. How would you find the area of that sector? Well, it is part of the area of a whole circle. Right? So we're going to need the area of a circle. But we can see that it's just a portion or a fraction, right? It's part of a circle of meaning multiplication. And it is some fraction or piece. Right? Piece of the circle. So how do you write that? Well, there's a couple different ways to write the fraction of it. And we're going to use degrees. So we know if we go all the way around, start from one place, go all the way around, we know that is 360 degrees. This central angle will have a degree. Your book calls it A, that angle here, which is the same as this arc measure here in degrees. In some textbooks, they will use the Greek letter theta. Now, theta will come back. They use it in trigonometry and calculus. So I wanted to show that to you just in case if you're looking at a video on YouTube or a different textbook or talking to someone else, you understand that sometimes people will use theta instead of A. So we're going to take this angle, and that's going to give us our fraction. So that degree over 360, going all around. So if you have 1/3, that would be 120 degrees over 360 degrees, times the area of the circle, which is pi r squared. And I should still be able to just write area of a circle, and you should know what that is, but I'm going to write it out specifically. And this equals the area of a sector. All right, so this is a formula. And you should be able to create this formula anytime because it's the fraction times the area of a circle. So let's practice that. So find the area of the shaded region. So it doesn't say that it's a sector, so you just need to be able to visually know it. And so we can see that it is a central angle, right? There's a center. The radii are here. All right, so remember that the formula is angle over 360 times pi r squared, the area of the circle. All right, so the area of this sector, what's my angle? That's 60 over 360. And I'm not writing degrees because degrees divided by degrees would simplify out to 1. And then pi r squared. And then my radius is 8. So I'm going to do some simplification. This is going to simplify to 1/6 and 64 pi. Now I'm going to leave it as an improper fraction. The numerator is going to be bigger than the denominator, but I will simplify it. So 6 does not go into 64, but 2 does. So I'm dividing by 2. So this is 32 pi over 3, and then no units. So we're just going to leave it. And you're like, you're going to leave it like this? Yes. It does not say to round, so I'm going to leave this as the exact answer. And so I'm leaving pi as pi. So for this next one, well, the shaded region is the blue part. So even though they give me 90 here, that's not the angle that I want. I actually want this angle. So if it's all the way around, it's 360, this is going to be 270. And 270. Now someone would say, well, Miss Mendoza, it looks like it's 3/4, right? Because 270 over 360 simplifies to 3/4. So pi over 36. Oh, sorry, that's 6 squared. I hope that's okay. My brain just jumped to it immediately. So I'm going to simplify that. So this time, 36 can simplify out, cross simplify. So I have 27 pi, and this time I do have units, meters squared. And there you are. So no, you don't have to find the whole thing and subtract that out. Nope. This fraction that tells you how much you want. Because I want 3/4 of the whole thing. So this is a different type of problem. So if you read the directions, this time it's asking for the radius and it gives you the area. So if you remember the formula, right? Area of a sector equals A over 360 pi r squared. Okay, so I have the area is 72 pi. The degrees is 80 over 360 pi r squared. Okay, so I'm going to simplify this out, and this is just simplification. I'm used to doing work without a calculator, so you'll see me simplifying things. You can do things the way you want to simplify, but this is just me. So I'm going to divide by 4. So that's going to give me 2/9 pi. Now if I divide by pi's, that will undo each other. I have a fraction, so I multiply the reciprocal. All right, so 2 goes into 72 36 times. I don't know what that is off the top of my head. 36 times 9. That is 324 equals r squared. So to undo a square, you're going to take the square root. So I'm going to take the square root of 324. That gives me 18. Perfect. And the answer is centimeters. Right. There you are. So this is area of a sector. Right. Our next shape is called a segment of a circle, which kind of sounds weird, right? But a segment of a circle is different than when we think of a line segment. Segment of a circle is a region between or bounded by a chord, right? But a chord is a segment where the endpoints are on the circle. And so it's the region between that chord and the arc. Right. So it's this nice shaded round region. So the question is, how do I find the area of that? So take a moment. How would you find the area of that? Well, we always break it down into pieces that we know. And so we're going to, when you think of composite, we usually add pieces or subtract pieces. So if I draw in these two radii, well, this region here then, arc bounded by radii, that's a sector. All right. And then this figure here is a triangle. So it looks like we have the area of a sector, and then we subtract the triangle. So we can create our own formulas, and once we know that, we can be more specific, and I can say, all right, what's the area of the sector? That was A over 360 times pi r squared, the area of a circle. Yes, put the parentheses minus. We know the area of a triangle is half base times height. Okay, so say this and that. And there you are. So let's try a problem. All right, so segment of a circle, find the area of the shaded region. So again, you have to recognize it for what it is. So clearly not a full sector. And you can see here's my chord and my arc. So that's a segment. And we said a segment is a sector minus the triangle. Okay. So I need the angle, and that angle is going to be 90 over 360. Or you could have just wrote that fraction, which is 1/4, right? Times pi r squared, it's 10, minus. So let's look at my triangle, half. Well, my base, it's a right triangle, so the base and the height are the legs. So it's 10 times 10. So we had said this is going to be 1/4. And this is going to be 100. So what's 1/4 of 100? Okay, that's 25 pi. And then this is 100, right? 10 times 10. Half is 50. All right, and they are not like terms, and you're like, Ms. Mendoza, let's put in pi. Nope, it did not say to use 3.14. So I'm just going to write centimeter squared. The reason why I put the parentheses around it and then put the units, because you're saying all of this is centimeter squared. Without the parentheses, you're just saying it's 50 centimeters squared. You didn't give a unit for this. So the parentheses, just like in regular math, you do it for the words too, saying that the whole thing is square centimeters. And again, didn't ask to round, so I'm just going to leave it like that. And it's easier to check your answers this way because everyone should have the same answer. The moment you round and you put in 3.14 or you use the button for your calculator, everyone can have different answers. All right, so our last shape is called an annulus. I sometimes, when I rush, I say annulus, so I pronounce it slightly different. And first of all, you need to understand what concentric circles are. So circles with the same center, but different radii. And we see them all the time. So you can see that. So you have two separate circles, and you can have more than two circles. Think of a bullseye or target symbol. Target. And you can see the two different radii. Here and here. But the center is there. So an annulus, okay, is the region between the two concentric circles. So here, that shaded region in between. That is an annulus. And so this is a common shape when they manufacture and make things. When you think of CDs, DVDs, Blu-ray, I think of it as a flat donut. Also, when you're talking about a washer, not like a washer and dryer, but a washer for the faucet or for anything with liquids, that little stopper in your faucet from leaking, it's a washer, a little ring that is an annulus. So how would you find the area of this lovely annulus or shaded region? You can see that I've labeled two R's. So you have two radii, and the bigger radius is capital R because it's the big one, right? And then smaller radius, or the smaller circle, is lowercase r because it's for the little circle. So how would you find the area of that? Take a moment, try to write it yourself. So it's the area of the big circle minus the area of the little circle, right? So if you can even just write that, right, then you can write a more specific formula. So using capital and lowercase r, this is the area of an annulus. That should make sense, right? Area of a circle minus area of the circle. And then we distinguish which one by capital and lowercase. All right, so I have two examples. So let's look. All right, so the first thing is to determine what is capital R and which is lowercase r. So I'm going to go with capital R. Oops, got my pen. So capital R is from center all the way out. That looks like it's 14. Lowercase r is from the center here. All right, so it is pi r squared minus pi r squared. So that is, oh, it's 196, right? Yep. 196 pi minus 49 pi equals 147 pi. Don't forget the pi. Many people forget the pi, and then if you just do write 147, that's wrong. If you forget pi, that's more than 3 times as much as that. And then don't forget your units because I give it to you. All right, so for this one, let's see. I'm going to do the capital R again. So that's from here to here. Oh, but I don't know that. 10 is only for this piece. You're right. So from here to here is 13. So that whole thing is going to be 23. And the smaller radius is 13. So pi r squared, pi r squared. I do not know what 23 squared is. 529 pi, 169 pi. It is 360 pi inches squared. Okay. There you are. So those are the 3 different regions that we talked about for circles: sectors, segments, and annuluses. All right. Thank you for watching. Bye.